Let's learn about a very important concept of thread priority. So let's say there are 10 threads in runnable state. However, there is only one available CPU. So only one thread can execute at a given point of time. Others will have to wait. So who decides which thread gets to run on the CPU? Well, the component who decides this is called as the thread scheduler. So each thread has a certain priority to begin with, and under normal circumstances, the thread with the higher priority gets to run on the CPU. Please note the keyword under normal circumstances. The priority value varies from 1 to 10 and it can be assigned to any thread. 1 priority is represented as the min priority and 10 priority is represented as the max priority. By default, the priority of a thread is 5 and is represented as norm priority. Norm as normal. Threads of the same priority are executed in FIFO manner. So the thread scheduler stores the threads in a queue. Now let's just spend some time to understand this part of normal circumstance. So what happens is all the main threads are started at a normal priority of 5, but still they are privileged to be executed first on the CPU by the thread scheduler. Why so? Well, it's by design. Since it's a main thread, it has to be executed first, otherwise your program will have to wait unnecessarily. So this is the first thing which gets to be executed in any case. Even though the priority of the main thread is 5, it gets the first priority to be executed on the CPU for the first time. Now let's have a code example to have a demo of the thread priority concept. So let's create this class called as thread priority example. Let's have a main method. We can get the priority of the current thread by calling thread.currentThread.getName. So let's print this out. Now let's get the priority of the current thread. So we can call thread.currentThread.getPriority. Let's print this out as well. Now let's get the current thread. So thread.currentThread.setPriority, and we have thread.maxPriority. Let's print the updated priority. Let's run this. So the outcome we will expect is the name of the main thread, then the current priority, which is the default priority because we did not change it earlier, and after we change it, what is the priority. Let's run and find out. So the name is main to begin with. The default priority is 5. We updated the priority to maximum and then we printed the same. Let's print something. So thread.currentThread.getName says hi. Now let's create one thread. Say thread1 says hi as well. And by default, the new thread, which is thread1, will have default priority of 5. Now let's give this the maximum priority possible, which is thread.maxPriority, and then 1.start. So what do you think will happen? Now that thread1 has the maximum priority and the main thread is still at the default priority of 5, I should expect that this one should be executed first. Then I should see the outcome for this one. So let's run it out and see what is going to happen. Well, what we see is the first one to get executed is main says hi, then the second is thread1 says hi as well. So please note that this property of main thread getting the first priority or the higher priority to get executed on the CPU, regardless of this having the lower priority, which is 5 as compared to the max priority, is only for the first time this thing gets executed. Once the execution starts, it will go by the FIFO manner, and then the thread scheduler will schedule the threads based on their priority, and if they happen to be of the same priority, FIFO will be used to schedule the threads. So this is how we deal with priority in the case of threads in Java.